Hey there. Today we're going to be talking about set matrix zeros. This is what the problem looks like, and what it's asking us to do is to take in a 2D grid, a matrix, and to do a pass over it. And in this pass, wherever we find a zero, that zero's corresponding row and column, we need to convert those values all into zeros as well, and do this for any zero we find in the grid. So I'm not going to draw anything out today, just going to jump straight to code. The first thing I thought of, which I thought was a pretty straightforward solution, which is what we're going to write, is to go do a pass through this matrix, find out where the zeros are and their corresponding rows and columns, and then we can do another pass through this matrix to explicitly set the zeros. Yeah, so let's just jump right to it. I'm going to write comments to describe what we're doing. So in the first step, we want to find all the zeros and create sets of rows and columns representing the zeros that are the rows and columns where we should set the zeros. And then after that, we'll actually go through and set those zeros. So let's do that. First, let's set our sets to store the rows and columns that we want to eventually turn into zeros. And let's do the pass through the matrix to get them. So for R in range length of matrix, these represent the rows, each row in the matrix. And for C in range length of matrix 0, we're guaranteed matrix to be at least length 1, so we don't need to worry about a null case. And so for this, we'll iterate through the entire matrix row by row. So in each element, we want to check whether they are equal to 0. And in the case that they are, we want to add that element's row and column to their respective sets. Cool. And that should be it for the first step. The next step then is to just take these sets, go back through them, and set those appropriate rows and columns to all values zeros. So for R in 0 rows, for C in range, well, I want to get the length of the columns or how many columns there are, but we've done that already. So I'm going to set a variable here, call length, and then put call length here as well. We want to set each of these rows, all the values to 0. And similarly for C in 0 calls, for R in range of, replace this variable. We're going to call it row length. Matrix R C equals 0. Like the problem asked, we were supposed to do this in place, which is what we did. So we don't actually need to return anything. They're just going to check that same matrix for our values. So let's submit this. And we did it. What is this problem's runtime? We went through the matrix once. So that's O of mn, where m is the number of rows, n is the number of columns. We just hit every element once, basically. In each of these loops here, the max number of iterations we could have done is to go through all the rows and all the columns respectively, meaning we would go through the entire grid once more for each of these loops. So that's another O of mn and one more O of mn after that. 3 O of mm's together, mn's together doesn't actually change the complexity, so we're still at O of mn time complexity. The last thing I want to talk about is over-optimizing, or knowing when to stop optimizing. Most of the time when you're asked LeetCode questions, of course, check your situation, but most of the times companies or whoever's asking you, they really just care about the category of time complexity that you get. So this is technically O of 3 mn. We go through it up to 3 times. And a solution that goes through the grid exactly once would technically beat it. But in terms of time complexity, they're the same. And if we only care about that n category, then this is a perfect solution. And I think this problem is a really good example of it because, like I said, the first solution I thought of was just to go through, find the zeros, and then go through 2 more times to just set the rows and columns. My usual first thought after that is to take my time and think, is there a better solution out there? Because usually the first thing you think of is not the best solution. But because I knew in this problem, we are given a matrix and we have to do something with zeros that are in indeterminate locations, we know that we have to check the entire matrix to find where the zeros are. And therefore our best possible runtime is already O of Mn. And so knowing that I had just thought of an O of Mn solution, I knew that I could stop right there and then just write it out. And that would be the categorically best solution for this problem. Yeah, that's it for this video then.